In this video, I am going to show you how to spin up a Kubernetes cluster. What is a Kubernetes cluster, you might ask? A Kubernetes cluster is a pool of computers that you can run a wide variety of applications on top of. You will only need a handful of prerequisites to follow along, namely an AWS account and a basic understanding of AWS fundamentals. The fundamentals being IAM, VPC, and EC2. IAM is how you create sub-accounts within your root AWS account, and you create these sub-accounts with limited or narrowed permissions. The more you use cloud platforms, the more you leave the option open for people to share or compromise your AWS accounts. In the case of compromise, you want to mitigate the amount of financial repercussion or data loss. VPC is related to networking. I am sure you have heard the phrase that the internet is the information highway. Highways are comprised of streets, of roads, of highways. The nodes of the internet are computers. You can connect computers together to create networks and subnetworks within bigger networks. The way that you create networks inside of your AWS account that are connected or not connected to the rest of the internet is through VPCs. The first thing that we will do is create an IAM role inside of our root AWS account that has the minimum needed permissions to allow us to create a Kubernetes cluster or EKS cluster on AWS. You can see in this document that I have linked below that there are 4 permissions or powers that we need to grant to this account that we are creating. Here is the first one, the Amazon EC2 full access power or permission. The way that you specify powers or permissions or policies is via these JSON objects, right? You can see that the first 2 are AWS managed policies. This means that by default, when you get an AWS account and you're creating sub-accounts, right, IAM roles for your root AWS account, when you're choosing which permissions or powers you want to grant to these sub-accounts, you will be granting these permissions from a list of powers or permissions, right? It's like cherry picking which ones you want to add to each sub-account. These 2 permissions will be available in that list of permissions that you can cherry pick and add to accounts. These 2 will not be, so we need to add them. Now that we have a sub-account that has the minimum necessary permissions for us to be able to create a Kubernetes cluster, we will move forward by implementing in a very precise manner what we see here in this architecture diagram. In this diagram, you see 2 green boxes or 2 VPCs. The top green box labeled AWS VPC, this is the control plane of our cluster. The bottom green box labeled Worker VPC, this is the worker or slave side of our Kubernetes cluster. The way it works is like this. We will usually use one of our devices, either our laptop or desktop, for example, to send commands to the control plane, usually using a tool called kubectl. It's a command line tool. The control plane will receive our commands and tell the workers to do what we are asking. This is pretty much what Kubernetes does. So the next 3 steps are going to be these. First, we are going to use the CLI to create the worker VPC. Then, in one fell swoop, we will use one AWS command to launch the entire control plane. It will come out of the box ready to go. Finally, we are going to rent some computers from EC2, right? This is what we talked about at the beginning. And we are going to plug them into the worker VPC network side of our Kubernetes cluster. Here is how we create the VPC. We can see that it is in progress now. Let's time it. So spinning up the VPC took about 3 minutes. We are now going to use the IAM account that we created to create another IAM account. This IAM account will be used by the control plane, and it will give the control plane all the permissions it needs to do its magic. Here is the policy for the account I'm using in the command line. I can edit it. So I see that the IAM create role action is here. I need to allow it on this resource as well. Is that right? I think so. View it, save changes. Okay, so it needs, then it went through. So sometimes it needs a couple seconds to update, but it went through, and now we have the ID or the ARN for the new role we just created. Yep. Now let's add a few more permissions to this new role. That worked. Now we are going to create the control plane in one fell swoop with this command. So this command only needs a couple of pieces of metadata about the VPC that it is going to be controlling. And the way that we get that information is by describing the VPC that we created with CloudFormation with this command. I'm going to run this in the Scratch folder. So if I come over to Scratch, JSON, search for subnets. So we have 2 public and 2 private subnets. We break our VPC network inside of our account into 4 parts. We do this so we can run some things privately and some things publicly. This is useful, for example, if you want to run a database that you don't want the internet to access, but you want anything that's inside your network to be able to write to your database. This is kind of like a layer of separation or protection against hackers. That's why you do a VPC network with a handful of public and private subnets. So we have this here. We will replace these subnets like so. And then we only need to get the security group. This controls which traffic can come into and out of the control plane VPC. And we should be able to run this. Yes, spin up. So this will create our control plane in one fell swoop. Let's see how it goes. Yep, it looks like it's going. So we can come over to the console just to verify what's happening. Yep, you see it's creating. We will time this. It usually takes about 10 minutes, if I'm not mistaken. Okay, so we did that successfully. Now let's rent some EC2 instances and wrap this baby up. So we need to use our IAM permissions to create yet another IAM role. This one is the one that will be used by the worker nodes of our cluster to do all the magic that they do. So, all right, we need to add this. And then save. One more time. It worked that time. So it takes a couple seconds to go through. Now let's attach some more permissions to this IAM role that will be used by our worker nodes. 1, 2, 3. And now let's launch our worker nodes with this command. Yeah, so it's creating. So when this is done, we will now have a functional working Kubernetes cluster that we can run Kubernetes applications on top of. Let me show you one last thing. This is how you plug your local kubectl command line tool into the Kubernetes cluster that you just created. You run this command, and now your kubectl command line tool will be executing commands against the Kubernetes cluster that you just created. And you can start creating Kubernetes applications. I created this one, for example. I will post the link to all of the code here, including all of the Kubernetes manifest code, that's what it's called, so that you can reference it and have fun building your own applications. Enjoy!